Hi guys, today we're going to look at recursive formulas for sequences. So if you remember, so far we've talked about explicit formulas. So the biggest difference between an explicit formula and a recursive formula, explicit formula will give you the term if you know the term number. So for example, if I wanted to find the 100th term of a sequence, I could just plug in 100 into the formula and it would generate the 100th term. If I want to know the 50th term, I'd plug in 50 for n and it would generate it. Recursive formulas means that you have to know the previous term. So the first day when we started looking at sequences and we had to describe a sequence, we said, oh, you just add 3 to the sequence or you multiply by 2. Well, that's really describing it recursively because we're saying what you have to do to the previous term. So recursive formulas mean what you need to do to the previous term, and that's how you write your equation. So for recursive formulas, you would have to know, if you want to know the 100th term, you'd have to know the 99th term so that you can know what term or what term you have to be able to add or multiply that term by some number. If I wanted to know the 50th term, I'd have to know the 49th term. If I want to know the 49th term, I'd have to know the 48th term, and so on. So recursive, you do the pattern to whatever the previous term is. So if we're looking at the difference here, explicit, so we have our two formulas that we talked about. We have our arithmetic formula and our geometric formula. So those are explicit, and n just represents the term number. And then for recursive, so this is the new part. You have two parts to a recursive equation. Since you always have to know the previous term, you have to have a starting value. So there's two parts to a recursive. The first thing is the starting value, that initial term. The second part is what we're going to call the recursion equation, which is basically telling you what pattern you're doing to the previous term. So if you look at this example right here, the recursive part is the starting value is a sub 1 equals 4, so you're starting at 4, and the recursion part is this section right here. So this is your starting value, and then this part here is the recursion equation. So really what this is saying is 2 times a sub n minus 1. So if you compare a sub n minus 1 to a sub n, this is the term before. So this part in green really means the previous term. And since there's a 2 in front, this really stands for 2 times the previous term. That's what it means. A sub n minus 1 means the previous term. So the pattern is you start at 4, and then you're going to do 2 times that number. So 2 times 4 would give us 8. Then we would take 8, multiply it by 2. So this is a geometric sequence because it's 2 times that previous term. It's just a different way to define it. So let's look at some examples on the next page of what these recursive formulas look like. So here's that example that we were talking about. So we have our first term, so a sub 1 is 4, very first term. And then remember, this part here, this is your recursive part, the a sub n minus 1, so that's the previous term. So what this is saying is multiply previous term by 2. So a sub n minus 1 means the previous term, so 2 times the previous term. So if I want to find the next number, so if I'm looking to find a sub 2 in my sequence, because this says we want to find the first 4 terms, that means I'm going to take 2 and I'm going to multiply it by the previous term. So the previous term is going to go here. That's what this formula is saying. So I'm going to plug in the previous term. It's 4, so I get 8. Then the pattern continues. So a sub 3 means you're going to do 2. So you basically use this recursive part, or the recursive equation, to generate your sequence. So you have your starting value, and then from there you're just going to keep doing that same pattern. So if you notice, I boxed in that a sub n minus 1 because that just means the previous term. And I keep this pattern the same. 2 times the box means 2 times the previous term. So then I take the previous term, I plug it in, generate the next term, so we get 16. Then again, for the fourth term, I have 2 times the box, meaning the previous term. That's my recursive equation. That's the recursive part, or the rule. And then I'm going to take what I just found and plug it in. So the previous term, so 2 times 16, we get 32. So this tells me that my sequence is all of these numbers right here. So it's going to be 4 times 8 times 16, or not multiply, 4, 8, 16, comma, 32, and the pattern would continue, but it only wanted me to come up with the first 4 terms. So this isn't something that you could just plug into your calculator. Explicit formulas you could plug them into your calculator, and you can look at the table, and when x equals 1, 2, or 3, those are the term numbers, and then you just copy down the y values. For recursive, you actually have to understand the process. So I'm starting at the initial, and then you just apply this recursive equation to it, to whatever the previous term is, and you just have to generate them by hand. So let's look at a couple more examples. So this first term in the sequence here, a sub 1, is -4. So then I look at the recursive part of this, and what this is saying, so I'm going to box in whatever that a sub n minus 1 is, because that's my previous term. So what this is saying, to find a sub 2, the second term, I'm going to take the previous term, remember that's what that box represents, and I'm going to add 5 to it. So what this is saying is it's the previous term, and like I said, I like to think of that previous term in the box plus 5. That's what it means. So take your previous term, -4, add 5 to it. You get out 1. Then again, for a sub 3, and I'm even going to just go ahead and write a sub 4. I'm just going to fill in like the template for it. So it's going to be the previous term plus 5 every time. Previous term plus 5. That's how you describe the pattern. So then I'm going to plug in the previous term. 1 plus 5 gives me 6. Take the previous term. 6 plus 5 gives me 11. So then that means my sequence is going to be all of those numbers. So it's going to be -4, comma 1, comma 6, comma 11, ... because the pattern would continue. So for these, it's easy to see right away if it's arithmetic or geometric without even having to look at the numbers that you're getting. Because if you look at part A, we were just multiplying by 2, so it's geometric, where part B, we're adding a number. We're adding 5 to the previous term, so right away I know it's arithmetic. So that's another way to look at it. Otherwise, you could look at the term numbers and you could just figure out the pattern again. But like I said, recursive really gives you that pattern. So let's just look at a couple more. So for these ones, these aren't going to be arithmetic or geometric, because I'm not just, if you look at the pattern for both of these, you're not just adding or multiplying by a number. You're doing something unique to them. So up top here, I was just multiplying by a number, so that's definitely geometric. I'm going to just add that. So this is geometric. And this one's arithmetic because I was just adding. But for these ones, you're going to square. So here's your recursive part. So you're going to take that previous term, you're going to square it. I'm just going to rewrite that squared. Then you're going to subtract 5. So let's go ahead and start this. So I have a1 equals 3. And then what I'm going to do is I'm just going to go ahead and I'm going to list out my terms. And I'm just going to write a square wherever I'm going to insert the previous term. Squared minus 5. So this is the recursive part. And then I'm going to go ahead and fill it in. So previous term, 3. 3 squared is 9 minus 5. So we get 4. So then that's going to go in. So we get 4 squared is 16 minus 5 gives me 11. Then that goes in. 11 squared minus 5. So we have 121 minus 5 gives me 116. So when you go to write your sequence out, we have 3, 4, 11, and 116. And the pattern continues, so we can put dot, dot, dot. This next example is a little bit different. Because of the fact that it uses this a sub n minus 1 notation, there's your previous term notation, but this n, that represents the term number. So what happens for this one when I set it up, I'm going to set it up a little bit differently. So a sub 1 is going to be negative 6. Then I'm going to start plugging in a sub 2 equals, okay, here's the previous term is going to go in the box, but then it's minus n. Well, n is always the subscript, so that's going to be 2. Then when I do a sub 3, it's going to be the previous term minus 3, because it's 3 is going in for n. So that's going to switch depending on whatever term number I'm looking at. A sub 4 is going to be the box minus 4. So then from there, we can start filling in. So this will be negative 6 minus 2 will give me negative 8. Negative 8 minus 3 give me negative 11. Negative 11 minus 4 will give me negative 15. So then your sequence is negative 6, negative 8, negative 11, negative 15. So that's how you can generate or find the first 4 terms, or however many terms if you want. But notice, again, with recursive, you always had to know the previous term. So let's look at the next page. And for this one, we're doing the opposite. They're giving us the sequence. Now we want to come up with the recursive equation. So the first thing you always want to do is you want to figure out what's the rule, what's the pattern, because that's really what a recursive formula is. It's how are you going from one term to the next term. So if I look at this, I see that it's a plus 3 pattern. So I'm adding 3. So it tells me, yes, it's arithmetic. So the rule is you're adding 3. So if we want to come up with the recursive equation, I'm not going to use the explicit formula. I'm going to be using this adding 3. That's what the rule is. That's what recursive means. What are you doing to the previous term? So your first term is 1. Then the recursive part is going to be, okay, well, it's the previous term. So that's the a sub n minus 1. That represents 1 less than n. And then you're adding 3 to it. So you take the previous term, you add 3. That's all it is. So it's a sub n minus 1 plus 3. So there's a recursive equation. Let's look at b. b to get from 5 to 10 times 2 times 2 times 2 and so on. So I'm multiplying by 2 is my rule. So start with your initial term. So you take 2 and you multiply it by the previous term. So it's going to be 2 times that notation for previous term, which is a sub n minus 1. So notice in all of these, this a sub n minus 1, that's the notation we always use for the previous term, because it's always 1 less than a sub n. So the pattern, you could do times 2 at the end if you want, but typically for multiplication you put it in the front, and then addition, subtraction, you put it at the end. So look at the next one here. So for C, now we're alternating between positive and negative. So that tells me it's going to be multiplication because it's alternating. So it means I'm going to be multiplying by a negative number. So times negative 2 would work here. So multiply by negative 2. So it's basically going to look exactly like B. The only difference is, and for the recursive part, instead of a 2 in front, it's going to be a negative 2 in front. So your a sub 1 is your starting term, so that was 15. And then it's going to be negative 2 times that previous term, a sub n minus 1. For D, again, you're alternating between positive and negatives, which tells me you have to multiply by a negative. And in this case, it's going to be times negative 2, because all of the numbers are just doubling. So same exact rule. So first term's negative 11, and then you're going to do negative 2 times that previous term, a sub n minus 1. So exact same equation. The only difference is what you started with. And for E, so this one has some negatives, but it's not alternating negatives. It's just gradually decreasing. So this tells me I'm going to be subtracting. So I'm going to be subtracting 1/2 for this one. So I start at 1. Let me write the pattern. So subtract 1/2, which really means that you're adding negative 1/2. So you start at 1, and you're going to take that previous term, so that's the a sub n minus 1, and you're subtracting 1/2, or you're adding negative 1/2. So there's the recursive. So that's looking at it one way. So we've looked at, here's your formula, come up with the sequence. Here's your sequence, come up with the formula. Now let's kind of compare the two. So let's go to the next page. And for these last set of examples, you're going to do a couple of things. You're going to write the explicit formula, then we're going to write the recursive rule, and then we're going to find the 19th term. So here's my sequence. So figure out the pattern first. So I'm alternating negatives. So it's positive, negative, positive, negative. So that means I'm going to be multiplying by a negative. So -3 in this case. So that tells me that this is going to be geometric because I'm multiplying. So if I want to come up with the explicit formula, here's your two formulas over here. Remember that these are given to you. The explicit formulas are always given to you on exams. Recursive are not, so you just have to know those. So for the explicit geometric, I'm using this formula. So a sub n equals a1 times r to the n minus 1. So if we plug in, a1 is 2, that's the first term. The ratio is what you're multiplying by, is -3 to the n minus 1. So there's the explicit formula, and you don't have to simplify that. Remember, you can't combine the -3 and the 2. The -3 belongs to the exponent and the 2 does not, so they have to stay separate. So then for the recursive part, the rule for this is to multiply, we already came up with it, multiply by -3. So that means when we go to write this, a sub 1 is the same thing. It's going to be 2. That's the starting term. But then you're going to take -3 and you times it by the previous term. That's the recursive part of this. So that's it. So the difference, so here's your two formulas. Here's the recursive formula versus the explicit formula. So if I want to find the 19th term, that means I want to know what term is in the 19th position, or what's the term in the sequence when n equals 19. You don't want to use the recursive formula, because if you use the recursive formula, you would have to know the 18th term, and to know the 18th term, you have to know the 17th term. If you think about plugging in 19 into this formula, you'd have a 19 here, which would become a sub 19 minus 1, which would be a sub 18. Then you'd have to know the 18th term to plug in, and you don't know that. So what you want to use is this explicit formula. So I'm just going to draw an arrow down and say always use explicit formulas. So whenever you want to find a term number, and it's not the first term or like the second term, you want to know your explicit formula. So I'm going to go ahead and I'm going to plug in 19 minus 1. So then I would simplify your exponent first. So it becomes 18. And then just put that into your calculator. You end up with 774. So 774,840,978. So there's your answer. So then the last one we'll look at together is this example 2. So the first thing you want to do is you want to figure out your pattern. So the pattern here, I'm noticing it's decreasing, so it's going to be subtracting 3. So this is going to be an arithmetic. So our explicit formula I'm doing first, that's from up top here, so that's this formula right here. So a1 plus n minus 1 times d. So we'll plug in. So I know a1 is going to be 11 and d is going to be -3. So a sub n equals 11 plus, don't forget that plus sign in between those, n minus 1 times -3. So then for this, remember you have to distribute that negative. So it's going to be an equals 11, and it's going to be negative 3 times n, which will be minus 3m. Negative 3 times negative 1 will be plus 3. So then combine your like terms here. So we end up with 14 minus 3n. So there's your explicit formula. Your recursive formula is actually a lot quicker to write because remember the rule is just add, I'm just going to call it add negative 3. So add negative 3, or you could say subtract 3. So the rule is really quick because the first term is 11, and you're going to take the previous term, which is that same notation every time, a sub n minus 1, because you have an, you want to know the term before it. So it's the previous term minus 3, or plus negative 3. So there's the recursive formula. So these are equivalent. They would give you the same exact sequence. The difference is the format. This one's more convenient to use, the explicit, versus this one's more of a pain to use, but it was a lot quicker to come up with. So if we're trying to find a sub 24, definitely go with this explicit formula. Use this explicit formula. Because, again, explicit formula, if all I have to do is plug in 24, where the recursive formula, I'd have to know all of the previous terms, 23, 22, and so on. So if I plug in, it would be 14 minus 3 times 24. So you end up with negative 58 as the 24th term. So then the last example on the next page, you guys are going to finish on your own. So this is on your own. And when you're all done, you will show me your answers for it. So on your own. So do that right now, and then that's it for the notes.